Section 4.6, Arithmetic Sequences. This might seem like we're going off the beaten path. Chapter 4 is all about writing equations of lines. And now all of a sudden we're going to talk about sequences. But it will make sense here in just a few minutes. Okay, we're going to start with a couple of vocabulary terms. First one is sequence. A sequence is simply an ordered list of numbers. Okay, and within a sequence there are what's called terms. And terms are each number in a sequence. So if I give you a sequence like this, like let's say I said 5, 10, 15, 20, and then it carries on, and then we could say a sub n, and then it carries on some more, okay? This whole thing, from start to wherever it ends, this is called the sequence, okay? This is the sequence, what I've got underlined in purple, okay? Each of these terms, each of these numbers in the sequence is a term, and this, obviously, the first number is the first term. Okay, the second number would be the second term. Then go back to a 2, second term, and so on. Now this one, this a sub n, this is what's called the nth term. And we don't know which one that is, but let's say we're asked to find the 15th term, then this would be the number we're looking for, or the 20th term, or the 25th term, or the 100th term, whatever it might be. Okay, so first term, second term, third term, fourth term, all the way down the line. This is the nth term. It's just a generic or a general term within the sequence. This is how we write it. It's a with a subscript, so normally we think exponents are superscript. Subscript is down below, and it's the letter n. A sub n is how you say that. Okay, another couple of vocabulary terms here. Arithmetic sequence, not arithmetic. Arithmetic is a sequence where the difference between any two consecutive terms is the same. Okay, and then that difference between any two terms in the sequence is called the common difference. Okay, so this is an arithmetic sequence up here because we go up by 5, go up by 5, go up by 5. The difference or the distance between them is always the same: 5, 5, 5, and so on. Okay, so the common difference in this sequence up here is 5. Okay, so the first couple of examples are going to be fairly easy. Write the next 3 terms of the sequence. Okay, so if we go from 7 to negative 14 in number 1, to go from negative 7 to negative 14, that would be down 7. To go from negative 14 to negative 21, that would be down 7 again. From negative 21 to negative 28 would be down 7 one more time. So for the next 3 terms, we just need to continue going down by 7, or continue subtracting 7. So negative 28 minus 7 is going to be negative 35. And then going down 7 more would be negative 42. And then 7 more would be negative 49. Okay, do the same thing with example number 2, negative 12, 0, 12, 24. To go from negative 12 to 0, we add 12. To go from 0 to 12, we add 12 again. To go from 12 to 24, we add 12 once more. Okay, so let's keep adding 12. 24 plus 12, that is 36. 36 plus 12 is 48. And 48 plus 12 is 60. The third example here, 0.2, 0.6, 1, and 1.4. To go from 0.2 to 0.6, that's up by 0.4. And then we add 0.4 again, and then we add 0.4 again. So our common difference here is 0.4, so we just need to add 0.4 to the next term. 1.4 plus 0.4 gives me 1.8. 1.8 plus 0.4 is 2.2. And 2.2 plus 0.4 is 2.6. So the next 3 terms, just continue adding or subtracting the common difference to the end of your sequence. All right, so like I said at the beginning of the video, this seems like we're going off the beaten path. It's writing equations of lines, finding slopes, finding y-intercepts, all that good stuff. And then all of a sudden we jump into arithmetic sequences. Well, how does this relate to lines? Well, let's do this. Let's graph the arithmetic sequence, and the question then becomes, what do you notice? So how I'm going to do this, I'm going to make an XY table. Okay, so position and then term. Okay, position and term. And my position is going to be what place in the sequence are these numbers. So this is going to be position 1, position 2, position 3, position 4. And these are going to be my X values. And then the term is actually going to be the first term is 4, second term is 8, third term is 12, fourth term is 16. Okay, so let's actually go ahead and plot these points. So I'm going to make a table here, or make a graph. I'm going to go 4, 8, 12, 16, just because it goes up by 4s every time, it makes sense. And then 1, 2, 3, 4. So I've got, let me label these here real quick, 4, 8, 12, 16, 1, 2, 3, 4. So if I plot 4 or 1, 4, that's right here. 2, 8 is right there. 3, 12 is right there. And 4, 16 is right there. And what I hope you notice is that an arithmetic sequence, when you plot them on a graph, they form a line. They form, whoops, let's spell form right. Form a line. Okay, so it does come back to writing equations of lines. The arithmetic sequence, or if it is an arithmetic sequence, will form a line. If it's not a line, then it's not an arithmetic sequence. Okay, so let's do some checking. Does the graph represent an arithmetic sequence? How can we tell? Well, remember, if something is linear, then there's going to be that constant rate of change from one term to the next. So if we made an XY table, okay, so position, term, okay, the graph gives us some positions, 1, 2, 3, 4, gives us the term, 15, 12, 9, and 6. You know, if this is obviously going up by 1 from here to here, so plus 1, and then plus 1, and then plus 1 again, and then to go from 15 to 12 is down 3, from 12 to 19, that's down 3, from 9 to 6, also down 3. So, what we can say, since we've got the constant rate of change, this is an arithmetic sequence. Yes, we can say arithmetic sequence. Okay, the common difference, remember that difference between, or the distance between each set of consecutive terms would be this number right here, the -3. That would be your common difference. Okay, let's take a look here at number 2. So, again, I'm going to make an XY table. So, position, POS, term, and let's make some values. So we got 1, 2, 3, 4 for our x's, our y values, 2, 4, 7, and 11. Obviously, the position line, they're going up by 1 every time, so plus 1, plus 1, plus 1. For the y values, whoops, hit the wrong button here. One more. There we go. To go from 2 to 4, that's plus 2. 4 to 7, that's plus 3. And then 7 to 11 is plus 4. So we don't have a common difference. We don't have that constant rate of change. So is this one an arithmetic sequence? No. No, there's no common difference, or there's no constant rate of change. No common difference. Let's just erase some of that. Common difference. So it's not an arithmetic sequence. Arithmetic sequence. Not an arithmetic sequence, because there's no common difference. And you can kind of see, if we graph this, this wouldn't be a line. It gets steeper as we go farther to the right. Okay, so how do we write arithmetic sequences? How we write it is this. We're going to do a sub n. Okay, that's for any term in the sequence. It's going to be equal to a sub 1, that's the first term, plus d, your common difference, times n minus 1. Okay, so what do all these terms mean? Like I said, a sub n, this one right here, this is your nth term. For whichever term you want to find in the sequence, this is how you're going to find it. Okay, so if I want the 25th term, that would be a sub 25. Or if I want the 10th term, it would be a sub 10. A sub 1, this one right here, this is your first term. Okay, you're going to have to know that at some point to be able to write the equation for the sequence. And then the last one here is d. The d is the common difference. Okay, so common difference. Common difference is d. Let me draw an arrow here for the red. Okay, first term is a sub 1. Common difference is d. Now, d can be negative. That's totally fine. If your sequence is decreasing, then you're going to have a negative common difference, and that's okay. Okay, so let's try one here. Write an equation for the nth term, then find a sub 25. So we're looking for the 25th term, but let's figure out the equation for the sequence in general. Okay, so we need to know two things. We need to know a sub 1. Okay, and that one in this case is 4. And we also need to know the common difference. Now, the common difference, how many up or down? Well, this is plus 1. And to go from 5 to 6, also plus 1. From 6 to 7, plus 1 again. The common difference here is 1. Okay, so once we know the first term and the common difference, all we need to do is plug everything into our equation. Okay, so let me change colors. I'll use purple here so we can say a sub n is equal to our first term, 4, plus our common difference 1 times n minus 1. Now, to make this, to clean this up a little bit, we can distribute the 1, and if we're really distributing a 1, it's not going to change. We're going to have a sub n is equal to 4 plus 1 times n is n, 1 times negative 1 is negative 1, and then we can actually combine our 4 and negative 1. So we can say that a sub n is equal to, usually the variable comes first, so we'll have n, 4 plus negative 1, or 4 minus 1 is positive 3. This would be our equation for that arithmetic sequence. Now, step number 2, or the second part, says find a sub 25. So let's actually do that. So the n value we're going to replace with 25. So we're going to say a sub 25 is equal to, well, there's n again, so now it's going to be 25 plus 3. So then we can say that a sub 25 is equal to 28. What that tells me is that the 25th term in this sequence, if I wrote out the first 25 terms, the 25th number that I would write is the number 28. Okay, let's try another one here. Let me scroll up here. Number 2, 8, 16, 24, 32, and so on. So we need to figure out the first term, so a sub 1. That's always the first number in your list. That's fine. That's 8. And then your common difference, let's see, to go from 8 to 16, we're going up 8. 16 to 24, up 8. And hopefully you can see that our common difference here is also 8. So our first term and our common difference are the same. Is that going to happen often? It's tough to say, but it can. And this is an example of when it does. Okay, so let's write our equation. We got a sub n is equal to our first term, a sub 1. So that's 8. Plus our common difference, also 8, times n minus 1. You're always going to have n minus 1 when you first start writing your equation, okay? So we can distribute here 8 times n, 8 times 1, so we'll have a sub n is equal to 8 plus 8 times n is 8n, 8 times negative 1 is negative 8. We can combine like terms again, 8 plus negative 8, or 8 minus 8, so we'll have a sub n is equal to, we still have the 8n, 8 minus 8 is actually 0, so this is our final answer here when it comes to writing our equation for the sequence. Now we actually need to go find the 25th term. So we'll replace n with 25. So a sub 25 is equal to 8 times 25. You don't need a calculator for this. Think about 8 quarters, how much money you would have. If I had 8 quarters, that means I would have $2. So the 25th term in my sequence up here for number 2 would be 200. So if I wrote out the first 25 numbers of that sequence, if I added 8 25 times, my 25th term would be 200. Let's try number 3 here. This one's actually going to have a negative common difference, and that's good to see too. So first term, that's positive 1. Actually I don't want A, I want D, common difference. So to go from 1 to 0, that's down 1. Let's slide that back up just a little bit. From 0 to negative 1, that's down 1. From negative 1 to negative 2, that's also down 1. So our difference here is negative 1. Our common difference is negative 1. Okay, so let's go ahead and fill things in. So we got a sub n is equal to our first term, which is 1, plus our common difference, which is negative 1, times n minus 1. N minus 1, again, is always going to be in your equation when you first start. Okay, so distribute here. So we'll have a sub n is equal to 1 plus negative 1 times n is negative n. Negative 1 times negative 1 is positive 1. Okay, so we'll have a sub n is equal to, we'll combine our like terms. We've got our variable first, negative n. 1 plus 1 is positive 2. So a sub n is equal to negative n plus 2. Now we need to find the 25th term. Okay, so a sub 25 is equal to negative, there's n, so 25 plus 2. The opposite of 25 is negative 25, so negative 25 plus 2. We can say then that the 25th term in our sequence would be negative 23. The last item in this section involves real-life sequences as functions. So how we're going to do that, we're going to replace a sub n back in this equation, this one right up here. We're going to replace a sub n with f of n. But otherwise, the rules stay exactly the same. So it's going to be f of n is equal to a sub 1 plus d times n minus 1. Everything else stays the same except we're replacing a sub n with f of n. Okay, so let's try a story problem here. The carnival charges $2 for each game after you pay a $5 entry fee. So you got to pay $5 to get in the carnival, and then each game is $2. Step number 1, write a function that represents the arithmetic sequence. So let's see. I'm going to make a table first. Okay, so if I figure out the number of games, I'm going to play and then my total cost. Okay, how much I'm spending in total to play that game. Okay, so if I play one game, that's going to be $2 for the game, plus that $5 I spent to get in the carnival, so that's going to be a total cost of $7. If I play 2 games, I still have to pay that $5 entry fee, but now I've played 2 games, so that's an extra $4 in games, so that would be $9. For 3 games, add another $2, that's $11. For 4 games, that would be $13. Okay, so we do have an arithmetic sequence here. Okay, our first term, a sub 1, if I want to play 1 game, that's going to cost me $7 total. Each additional game, the common difference between the number of games is going to be $2. Okay, so let's figure out our function here for the sequence. Okay, so we'll have f of n is equal to our first term, 7, plus our common difference, 2 times n minus 1. Every time we're going to have n minus 1. We can distribute here, so we'll have f of n is equal to 7 plus 2 times n is 2n. 2 times negative 1 is negative 2. Okay, so then we'll have f of n is equal to, we can combine our like terms. We still have the 2n, that'll come first. 7 minus 2 is plus 5. And that should make sense. This kind of, the 5 represents the one time you have to pay that, and then $2 times the number of games. This would be our equation right here for the sequence in number 1. Number 2, graph the function. So we know it's an arithmetic sequence. We know that this should form a line. This should make a line when we graph this. Okay, so 2, 4, 6, 8, 10, 12, 14, 16. So I'll go 2, and then this is 6, and that's 10, and 12. 1, 2, 3, 4 games played. Okay, so I'm going to just use these data points up here. So I had 1, 7. 1, 7 is about right in there. And then I had 2, 9, which was there, and 3, 11, which is just short of 12, somewhere in there, and then 4, 13, and it looks like that. Now, you're not going to actually draw a line between anything because, we can't play a game and a half. We can't play a half a game. We can't play 2.5 games or a quarter of a game. So we're only going to have points on the number of games, the whole number of games. Last question here. How many games can you play when you bring $29 to the carnival? Well, $29 is not a number of games. It's a total cost. That would be like our Y value. That's what would go in place of f of n. So what we're going to do, this 29 goes right there, and we're going to solve for n. Okay, so we're going to have 29 is equal to 2n plus 5. Okay, and now we're just going to solve for n. This is a two-step equation. Subtract 5 from both sides. 29 minus 5 is 24 is equal to 2n. And then we just have one more step, divide by 2. 24 divided by 2. We can say that we can play 12 games when we take $29 with us to the carnival. Because remember, we have that $5 entry fee, which leaves us with $24 for games. And then games are $2 a piece. 24 divided by 2 gives us 12.